and perimeters and areas, it's really, really easy. And I'm just going to do a couple quick examples here with you guys and give you a couple of problems. I don't want to get, like I said, I know that there's a lot going on. I don't want to get too far into this right off the bat, but it's pretty quick. One of the things that we've done when we did similar figures first semester, we knew that if you had similar figures, got those two, similar figures had congruent angles, but their sides had a common ratio. Remember when we did that with triangles? We had similar triangles, they all have congruent angles, and their sides had specific ratios. Well, that's what all this works from. So what we're going to do here is that if you have this thing called your sides, we had perimeter, and today we're going to talk about area, what the ratios of that would be. When we have the sides had that common ratio, remember it was called scale factor? Remember that? What's that? I heard, yeah, I remember there was one on there. And then we're gonna, once you start seeing this, you'll be like, oh, this is super easy. Now, one of the really, really easy things to do here is that if you have sides have a ratio of 2 to 3, that means the perimeter has a ratio of 2 to 3, and we did that before. Now, what happens here then is that the areas will have a ratio of close, but 4 to 9. You square it. Be 4 to 9. What happens here is that if you have an A to B ratio for your sides, you have an A to B ratio for your perimeters, which means you have an A squared to B squared for your areas. It is quite literally that quick. Okay. What we are able to do with these things then is that if you know your scale factors between two figures, and you know one figure's area, you can figure out the other area. It's really quick. Okay? Let me show you an example. Let's see. Oops, sorry. 27. So if these two guys are similar, remember a single squiggly meant similar? So if I'm going from left to right, and it has they're similar, I would say 4 to 10 is the ratio of the sides. When I take 4 to 10, what does that simplify to be? 2 to 5. Very good. Remember, whenever we talk about scale factor, we always simplify our fractions. So you get your scale factor of 2 to 5. That's your ratio of the sides. If your sides have a ratio of 2 to 5, what would the areas have a ratio of? 4 to 25. Very good. So the area would be 4 to 25. Now I'm going from left to right. Small is on the top, big is on the bottom. If I know the area of the small one is 27.5, does that can go to the numerator or denominator? Numerator. What do you do to solve for x? Exactly. You just cross multiply. What you're doing here is you're taking the ratio that they give you, simplify it. In this case, we have a size, we have to square it, and then just write in your ratio. So if you cross multiply this, you can get 4x equals whatever 25 times 27.5 is. I'm sorry, what was it? 687.5. Thank you. And then lastly, what do I do to solve for x? There you go. Pretty quick ended. And what'd you get? 171. There you go. Yeah, like I said, there's not much to it. It's pretty easy. Okay, it's pretty easy. Remember, this is the ratios of the areas. This is the small area, and this is the one that we don't know. You're going to either find the small one or the large one, and it's just a matter of making sure you put it in the correct order. Let's try it over. The scale factor of two parallelograms is 3 to 4. The area of the larger is 96. What's the area of the smaller? So if the scale factor is 3 to 4, so I'll spell. If the scale factor is 3 to 4, what would the areas ratio be? Very good. But 9 to 16, yeah. That gives you an area ratio of 9 to 16. If you know that the larger of the two areas is 96, does that go to the numerator or the denominator? It goes to the denominator because 16 is bigger than 9. Cross multiply and solve for x. It is quite literally that straightforward. It says the area of the larger is 96. So if you're going from 3 to 4, 4 is bigger than 3, so that means that's the larger of the two. And then 9 to 16 is still larger, which means the 96 has to be the larger. And it's a matter of how you set it up. Right? And cross multiply that, what do we get? 16. Oops, grab the x. 16x is 9 times 96. What'd you get? 54. Thank you, sir. There you go. So even though we only had 10, 15 minutes to get through this, it's pretty easy. Yeah. What happens if you knew your area and you had to find the scale factor? What would you do to the area ratio? Very good. Do you guys know how to do a square root in your calculator? Do you know you can do that with a fraction too? No. Speaking of, these two guys are similar. There's your area ratios. What is the ratio? What is the ratio of the perimeters? Remember, the perimeters will have the same ratios as the sides. The perimeters will have the same ratios as the sides. Will have the same ratios as the scale factor. So if I'm going, if I'm looking at this, I'm saying 50 to 98 is my, excuse me, 50 to 98 is my ratio. Excuse me. First thing I have to do is put that in my calculator to simplify it. When I simplify that, what do I get? Good. So the first thing you do is always simplify it. So there's your area ratio, which means what do you do to find the scale factor? What's the square root of 25? And what's the square root of 49? So your ratio of the sides, or your perimeters, would be 5 to 7. Which then means you can figure out side lengths if you had to. Right. I didn't want to get too crazy into this. I know there's going to be more, there will be more to it, but for the first start out, it's really all we need to worry about. So, let's see. Right problem says. Then we'll finish this out tomorrow. So this is 10th form in the book. Let's do those for right now. We'll continue on from this in a little bit. And we'll get a little fancier with it tomorrow. But for right now, that's all we got to worry about. Okay?